Hey, welcome to day 30. Yesterday we built this API. That's the homepage of the API, and that's one API URL example. There, so that returns a dictionary. But this dictionary for now, it's just some fake data. So we are returning that dictionary in this line. Basically, we simply get the station and the date from the user via the URL. So here, station 10, that's the date. And then we simply return that dictionary with that value for station and that value for date. The temperature is also fake. So these are all fake data. What we want to do today is we want to get the temperature out of the actual dataset. So I'll give you the dataset in the next video, and we're going to load the dataset in Python and extract the temperature for any particular station for any particular date. Now, before we do that though, we need to explore the data via Python. We need to understand what these data are about. And how do we do that? We do that by using Pandas and Jupyter. You already know what Pandas is. And Jupyter is like a code editor, like PyCharm, but it's quite different. It's designed specifically to code for data analysis purposes. So in other words, Jupyter is designed to work with Pandas, actually. I don't want to go into further detail about Jupyter. You'll understand what it is about exactly in the next video, where I introduce it to Jupyter, I show you how to use it, and then we will analyze the weather data file that we have with Jupyter and Pandas. So I'll see you in the next video. Hey, welcome back. In this video you learn how to use Jupyter. Jupyter, as I already mentioned, is a code editor, but with some special features. You'll see exactly what those features are in this video. So we will do two things here. First, we will install Jupyter, and second, I'll show you how to use Jupyter. To install Jupyter, you should go to jupyter.org. Note that this is with a Y. Jupyter, the planet, is with an I. So once you go there, you should go to install. Now here you can see the installation instructions. However, these instructions are generic and they change slightly depending on your operating system. That's why here I'll keep two operating systems open. Here on the left I have a Windows machine, and here on the right I have a Mac machine. So I'll tell you exactly what you need to change during the installation depending on your operating system. So if you are on Windows, Mac or Linux, you'll know exactly what you need to do to install Jupyter correctly. So if you are on Windows, you should go to the Start menu and search for Command Prompt. So that is my command prompt. And if you are on Linux or Mac, you should search for the terminal. Then, on Windows, you should type in py minus 3 points. In my case, that would be 11. So I have 3.11 installed on my computer. In your case, it could be another version. So whatever you've been using, you should place that version in here. On Mac or Linux, that would be Python 3.11. Same thing goes here, you should adjust that version. If you don't know what version you are using, then try to press enter here. So py minus 3.11, press enter. And if you see these arrows, that means you do have that version. So if you see the arrows, then to exit with parentheses to go back to the terminal. So you should be in the terminal now, as you see here. If you got an error, then try py minus 3.12 or py minus 3.10 or py minus 3.9, depending on what you have. Same goes for Mac, so try to search. Yeah, Python 3.11 is available in my case, so I'll do exit parenthesis to go back to the terminal. Now that we are back to the terminal, we should do again py minus 3.11 minus m pip install Jupyter lab. For Mac or Linux, that would be Python 3.11 m pip install Jupyter lab. So press enter there, press enter here. And that installed Jupyter Lab on Windows and also on Mac and Linux. So now we are ready to start Jupyter Lab. Now to do that, we first need to close these terminal windows. Then you want to go to a specific directory. For example, let me go to downloads. So this is just a folder, it could be any folder on your computer. So this will be the folder where you want to create the Python files or any other associated files. So this is the equivalent of the project directory we have in PyCharm. So open a folder on Mac and Linux too, and then you want to go one level up that folder. And you want to click on that folder. So do the same for Windows. Right click over the folder and then go to open in terminal on Windows, and on Mac you should do the same. Right click, go to services and then go to new terminal at folder. On Linux you should also see here open in terminal or something like that. So new terminal at folder, and that will open the terminal program pointing at that particular folder, downloads. Now we will start Jupyter Lab, and Jupyter Lab will open in this particular directory. So Jupyter Lab can be opened from the command line using the Jupyter -lab command. Same here, Jupyter -lab command. So press enter, and that will open Jupyter Lab on your browser. So here is on Windows and here is on Mac. And this opens in that particular folder, downloads folder in my case. Then what you want to do is you want to create a Jupyter document by clicking on that icon, so this icon here. And from now on, the instructions on Mac and Linux and Windows are the same, so I'll just use only one of these operating systems. So that's a Jupyter document, and this here is a Jupyter cell, and inside cells we can write Python code such as print hello. To execute the code, you should press Ctrl Enter on Windows and Linux or Command Enter on Mac. That will execute that code and you'll get the output instantly. You can add more code in that cell by clicking over the cell and then press Enter and add hi, for example. Press Enter to add a new line, hi again. And to execute the cell again, you want to press Ctrl Enter or Command Enter. So there you go, we get the results of all this script. So we have a script here written in a cell, and we can create multiple such scripts by pressing this plus icon, or you could just press B on your keyboard. But first, before you press B, you should press escape, because currently our focus, the cursor focus, is inside the cell. So press escape and then press B. That will create a new cell. Then press enter to enter that new cell, and here you can write code again. Hi, I'm another cell, Control enter to execute it again, escape B, enter, and you can continue writing code like that. Now you would ask, what's the catch here? What's the benefit of this Jupyter notebook? Well, as you can see, this is very similar to the Python interactive shell, so you can code quickly and you can keep your code manageable, organized in separate cells. The big difference here, though, between a Python interactive shell, you know, the Python shell where we code here. So this is the Python shell, just wanted to remind you in case you don't know what I'm talking about. So the big difference between that Python shell and this Jupyter notebook is that once you close the Python shell, the code you wrote there is lost. And this is not the case with Jupyter, because here we have created an untitled.ipynb file. So this is an actual file, and if you go to the folder, in my case downloads, where we started Jupyter Lab, you'll see that we have that file actually here in this folder, untitled. So now what I'll do is I'll give you a demonstration. I'll close this file, and to close it you can either close it here, or if you want to stop Jupyter, you want to go to the terminal, to the command prompt where we started Jupyter Lab. You see here I ran this command, and this window should be kept open for Jupyter Lab to run. If you want to stop Jupyter Lab, then you want to close this window. So that means we have stopped Jupyter. So even if you try to run this now, like to run some code, like print 10, Jupyter Lab will not allow to do that. So we have lost the connection. So we can close this page, and to open again Jupyter Lab, maybe you start working tomorrow again, you want again to open the terminal first, the command prompt, and then Jupyter -lab, press enter, and that will open the browser automatically. But you should be careful here, because what I did actually is I started Jupyter Lab in this directory, users/as. Therefore, what I see here are folders and files of that particular directory. So these, for example, are files I've created earlier in that directory, users/as. So if you want to open Jupyter Lab in one particular directory, again, what you should do is you should close this window, go to that particular directory, so downloads, and do the same process that I showed you. So right click and go to open in terminal, or on Mac that would be services and then open folder in terminal, and then here you should run Jupyter Lab again. This time that session should be pointing to that downloads folder where we have these two files, and to open the previous document we were working on, you should right click it, and that will open the same code we were been working on. It's a good idea to give this a name, so right click over that file, go to rename, and just give it a name. So as you can see, Jupyter Lab is like a hybrid between a Python interactive shell and an IDE. Now you might ask, well, can we use Jupyter Lab instead of PyCharm for any project? The short answer is no, you cannot do that, because when you write a program in Python, you might have several Python files. So these are .py files. But Jupyter creates an ipynb file. So that is not a .py file. This is a notebook file where you write this kind of code in different cells. So Jupyter is designed to be used when you simply want to explore some code. And this is particularly useful when you want to load some data with Pandas and then print out the first 10 rows perhaps, do an average of a column of the data frame, maybe plot a graph. You can also plot graphs here on Jupyter Notebook, which is also one of the differences between a Jupyter Notebook and a Python shell. So you can see the graphs in here. So in the next video, we will use Jupyter Lab again with Pandas. We will explore some data sets and I'll teach you Pandas in depth, so you'll learn some advanced concepts of Pandas. And then we will use Pandas for our API. But before we use Pandas with our API, we want to explore the datasets in Jupyter. So let's do that in the next video. Thanks. As you know already, we are building an API which will serve weather data for any station in Europe for any date, historical data. Now, before we code the data part in PyCharm, it's a good idea to open Jupyter and explore the data. So in this video, we will explore the dataset we have and I'll give them to you. Plus, this video will be an in-depth tutorial on the Pandas library. So before we begin, please download one of the zip files from the lecture resources. Which one should you download? I do recommend you to download datasmall.zip. So the data.zip file, once you extract it, contains a folder and you have there about 6,500 text files. So one text file for each weather station in Europe, in the European continent. And Datasmall has only the first 100 text files out of all those 6,500 stations. So for this course, it is enough to work on the Datasmall dataset, only on these 100 stations. But if you want to sell the API later on, then you might want to have the complete dataset so that users, real users, can query any station. For now, I do recommend you to just download datasmall.zip, extract it, get the folder and place it somewhere in a directory. I do recommend you to place it in a separate directory from your PyCharm project directory where we have been working on, because Python versions could get messed up. So please place data_small in a folder. For example, I have that in this folder named 3. I'll right click here and go to open in terminal or wherever you have there, as I showed you before. So that opened the folder 3 in my terminal, and there I'll do Jupyter-lab, so Jupyter-lab, press enter, and that should open the browser pointing to that folder. So I have data_small here, and I can delete these other folders and files because I don't need them. So to keep the directory clean. And then here we want to create a new Jupyter Lab document. So it is by default titled untitled.ipynb. So I'll right click here and give it a more meaningful name, such as tutorial. And let's begin. So the first thing we want to do is we want to load one of these files in Python with Pandas. But let me explain you what these data are about. So we have this stations.txt file, which looks like this. So you can open these text files in Jupyter Lab and you can view them. You can also modify them, but be careful not to modify these data because you'll corrupt them and you'll not be able to read them correctly with Pandas. So the stations.txt file has a list of stations. That's the header of the data, and these are the stations. So this is actually the metadata of the actual data, which is these ones here. These are the actual data. So this gives some information such as the latitude and the longitude coordinates of each station and the height of that observation station. So that's the altitude of each station. You can read more about these attributes in these lines. So we'll not be using this stations.txt file. What we're interested about is each of these data. So for example, this first file has weather data for the first station, which is this town in Sweden. And so we have many towns across Europe, Frankfurt, Münster in Germany, etc. So this first one is about that town in Sweden, and the actual data start at line 22. 21 is the header, and you have several columns here. You can read for these columns what they are in these lines. So we have the station ID, we have another identifier, this one in here. So the station ID is one for all the observations, because we have different observations for different days, but for the same station. So all these data in this text file are for this particular observation station. So for example, this record here, this row here was recorded on this date, which is year 1860, so that's about 160 years ago. And for January, 1st of January. And the temperature was 2.1 degrees Celsius. So Tg is the mean temperature in degrees Celsius. Now, these values have been multiplied by 10, so the actual value is 2.1. The reason they have multiplied it by 10 is to keep the data in a smaller size, because you are avoiding the comma character for all the data. So you should keep that in mind when you do calculations with these data. You might have to divide all these values by 10 to get the actual temperature, and we'll do that in Jupyter. And then we have QTG, this last column, which is a quality code. So 0 means this was a valid observation. And that's what we have. So we have daily data, daily average temperature data up to somewhere in the current years. And the same is repeated for every observation station that is available for these data. So these data were taken from the European Climate Assessment and Dataset Agency. Right, now let's go to Jupyter and import Pandas as PD. If you get an error, then you might need to open a terminal again, and here you want to do py minus 3.11, depending on what version you used to install Jupyter Lab. You remember in the previous video, whatever version you used, say py minus 3.11 pip install pandas. If you are on Mac or Linux, this should be Python 3.11 or Python 3.10, whatever version you're using. So execute that, and that should install pandas. And besides pandas, you should also install another library called matplotlib. You can use the same command, so Python 3.11 pip install matplotlib. So execute that as well, and that's about installing the required libraries. And then go back to Jupyter and you should be able to import pandas. So Control Enter or Command Enter to execute the cell. If you get no errors, that means pandas was imported. So then you can press Escape B to create a new cell, Enter to enter the cell, and you start typing here. So let's create a data frame using pd.read CSV, and here should go the path to the file you want to load. So we will work with one of these files for now. So let's choose one. Let's choose the first one in here. So I'll right click over this file and go to copy path and then provide that path in here. So you see this is data underscore small slash the name of the file. So that is the relative path of this file relative to the tutorial.ipynb file. Execute that. And the first thing you will get is an error. Error tokenizing data. This is a common error when Pandas is not able to parse the data. So it means that the data are not in a well-structured format. And that is true because we have these descriptions here, which are not actual data. And now you have two options. You either want to manually delete these, which I do not recommend. I do not recommend to delete these lines because there is another method, and that is by providing a skip rows attribute argument here. So how many rows do we want to skip? That is 20 rows, right? Yeah, 20 rows. We only want to keep the header and the data. So let's say 20 here. And I also want to add another argument, parse dates. And that is equal to a list. And in the list, I want to tell Pandas that I do have a date column here, so that Pandas can treat this as dates. So the date column is this one here, but be careful here. It's not date, so it's not date, but it is actually date with some leading spaces. So to get the actual name of the column, you want to copy the entire length of the column, starting from where the comma ends here up to the next comma. So that's the actual name. So inside the quotes, you want to paste that full name of the date column. Then press Ctrl Enter to execute that cell. No errors. Now we're ready to display the data frame. So press B to enter a new cell, DF, press Ctrl Enter, and you'll see the data frame printed out. This data frame has 59,321 rows and 5 columns. I can see that in here, but you can also tell that by looking at the last index of the row of the last row. So this one on the left is an index column which is assigned automatically by Pandas. So here we don't have that index column. As you can see, the first column is stat ID, but Pandas assigns that column by default. It starts from 0 and up to the last row. So that means 59,321 rows. So that is the index column. Then we have the normal columns, these ones in here. And so in this view of the data frame, we only see the first 5 rows and the last 5 rows. Obviously, Jupyter will not display the entire data frame because that would be too big to fit in this document. So if you want to view particular sections of a data frame, you need to use data frame indexing. So let me show you that to you, how to do it. Before I do that, I do recommend you to close all the tabs with these text files because they will slow things down on Jupyter. Also, I do recommend you to divide the sections with headlines. What do I mean by that? Well, for example, you can click over the first cell, make sure you are outside of the cell, not inside like that. If you are inside, press Escape. So make sure this cell is selected like this, and then press A on your keyboard. That will add a new cell. Now, as this new cell is selected, press M. That will turn the cell into a markdown cell. What does that mean? Well, that means that you can write markdown code here. For example, load the data frame. If you press Ctrl Enter or Command Enter now, that will execute that markdown cell showing the actual text in big font. So if you want the text to be smaller, you should add 2 hash symbols and so on. I'll just keep it with 1. So we loaded the data frame in this cells, and then I'll select on the last cell, press B to add a new cell, press M to turn it into markdown cell, and say here show certain rows. Then press Command Enter to execute that, B to create a new cell, Enter, and now we can do df 10 to 20, for example. Execute that, and that will show you rows starting from row with index 10 up to row with index 19. So this is the same syntax as with lists. Next, to show certain columns. Now here is a tip. If you want to execute this cell and create a new cell in one single keyboard shortcut, you can use Alt-Enter or Option-Enter on your keyboard instead of Command-Enter. So with Alt-Enter, that will execute this cell and it will create a new cell in the next line. So here we can write some code, such as df. Let's show this tg column. But if you do tg like that, you'll get an error because there isn't any column with that name. Actually, the column name is a bit different. So to have all the column names somewhere, first do df.columns, and you'll see that tg is actually it has this name with some spaces in front. It's about 1, 2, 3 spaces, I believe. But to make sure, you want to copy that, including the quotes, and then in the next line you do again df with square parentheses and paste that string. Execute, and that should give you only that particular column. If you want multiple columns, again do df square brackets, but then again you want to provide the names of the columns in a list. So let's say tg, comma, let's include the date as well. So copy the date column because these as leading spaces as well. So that's a list inside square brackets. Execute, and what you get now is this data frame with 2 columns. There are 2 important points to be made here. First is that in this line of code here, this returns a data frame series object, and this here returns a data frame. So a data frame series, a Pandas series in other words, is like a data frame but with 1 column only. So it's a series object, and this here is a real data frame object. So in this case, Pandas produce a data frame because we have multiple columns, and in this one, Pandas produce a series. That's just something to know. So that was the first point I wanted to make, and the second point is that you should know that we are not modifying the data frame here. So this is like a method that returns something on the fly, but it does not modify the data frame. If I print out the data frame again in here, you'll see that this is exactly the same data frame as this one, which we printed in the very beginning. So all these pieces of code, they return something, and that's all. So this is just to explore the data, to understand the data. But to understand the data further, you want to apply some simple statistics. So let's have a section on simple statistics. For example, you may want to know some information about the temperature column. You may want to know the average temperature for all times. So you want to point to TG, make sure to get the correct name of the column, including the spaces. And then outside of the square brackets, you want to apply .mean. So mean is a method of a Pandas series. Remember that dftg returns a Pandas series, right? We have the same code here. So dftg is a Pandas series and mean is a method of a Pandas series which returns this. Is it really that the mean temperature is minus 991 degrees Celsius? I don't think so. So there is a problem here. In the data, if you see the recent data, they have these minus 9999 values for temperature. This is usually a convention for data which are missing. So the data providers usually write these values for days where there were no observations. And as a data analyst, you should make sure not to include those observations in your analysis, in your statistics. So in that case, we want to filter out these values. So to do that, delete that. Let's update the headline here, simple statistics and filtering. So we want to apply statistics on the actual data. And to get the data without those minus 9999 values, you want to do df.log to square brackets. And inside the square bracket, you want to say df square brackets again. And inside the inner square brackets, you want to place the TG column name. Then do exclamation mark equal minus 9999. Press enter. And that will give you the data frame, but without those minus 9999 rows. So you only get actual data, real data. Now, what is this? Well, lock is a method of the data frame and it is used when you do conditioning such as we do here. Inside lock, what this is actually is the condition. So you place the condition here, which in our case is this. So the condition is that we want to get the data frame where the TG column is not. So this means it is not equal to minus 9999. So with that, we filter out the data frame to get only these. So this is what is returned. Again, the data frame is not modified. Again, if I print out the data frame in here, you'll see that we still have these minus 99999s. And it's not actually a good idea to update the original data frame. So please don't do that because you'll run into problems. What you can do instead is, since this is the data frame, then you apply mean here, like that. And I applied the mean to the entire data frame, but if you want to apply the mean only on the TG column, then you want to do this. So what we have here is this returns the data frame and that returns only that column of the data frame, so a series. So the TG column without those minus 9999 values. And on top of this TG column, we can apply the mean, finally. So that's the mean. Of course, this has to be divided by 10, as I mentioned already, to get the actual average temperature for this station for all times, 6.36. Similarly, you could get the maximum and the minimum, so just copy that code, place it here, and instead of the mean, we want max. 26.2 is the maximum temperature. So this is a maximum daily average, right? All these values are the average for each day. Similarly, you can copy that, place it here, or you can simply do CC and then V to copy the entire cell. So again, let me delete this cell. To delete the cell, make sure you are outside of the cell, not inside like this. So outside, DD to delete. To copy a cell and paste it, make sure you are outside of the cell, CC and then V. And then change this to min. So the minimum was minus 28.8. Right, so we have the average and we have the maximum and the minimum. However, these are not enough to get a good understanding of what our data are. And so we could use an histogram to get a better view of the data. Let me explain you what a histogram is and how to create it. So we want to create a histogram like for one particular series, for example TG, like that, using the .hist method. Press enter and that should create this histogram. However, this does not depict a good picture of the data because the TG column here has those fake data. So we want to apply hist over this part. So excluding the minus 9999s. And that's what we get. So let me explain you what this is. The horizontal axis represents temperature. And the vertical axis represents the frequency of those temperatures. So that means the temperature between -2 and perhaps 10 has been measured more than other temperatures, so we have more occurrences of those temperatures in this interval. So most of the time the temperature in this town is about -2 to 10, and then very rarely we have temperatures about -20 and -10. And so is the case for the other extreme, which is the hot days in here above 20. So with this histogram we can see how our data are distributed. Next section. So far we did loading the data frame, show certain rows, show certain columns, some statistics, and now I'll show you how to show certain cells or get certain cells. So let me show you the data frame again, and then let's get the value for this cell 31. How do we get the temperature for this date? Well, to do that you need to use lock again, and then inside the lock goes the condition, right? So condition would be df square brackets. So we set where the date is, the exact name of the date column is this, so I'll copy that to avoid typos. So where the date is equal to that. Now let's see what we get out of this. So I'll put it in quotes. Press Command Enter or Control Enter, and this is what we've got. So that's the entire row where the date was that value. So that's the entire data frame, but with only one row, and that row is the row that has this date. So this is actually a data frame. Let me prove that to you. It's a data frame, right? So out of that data frame now, we want to access the TG column. So TG is this. So that will give us this series. So we're still in a series level. And to get the actual value, 31, you should apply the dot squeeze method. And finally, we get 31. And of course, you need to divide it by 10 to get the actual degree Celsius temperature. Another question, how do we get the date when the temperature was the highest? That would be df.log. So the condition this time is df tg. So the tg, the temperature, should be equal to df tg.max, so the maximum. Press enter, and that's the row that has the maximum temperature that date, and the temperature was 26.2. So if you want to extract only the date, of course you can do that. That will give you a series, and that squeeze should give you the date only, like that. It's a timestamp object. So that's how you query certain cells. And these were queries by condition, which is what you want most of the time. But if you want to query by coordinates, let's say df.log, in square brackets, you can just say, for example, if you want 37, by coordinates, that would be 3, so the index 3, and the column tg. If you press enter, you'll get the actual value. So that's pretty easy. Now I'm getting a bit annoyed by having to divide the values of the TG column by 10 all the time. Should there be a more permanent solution to this? Well, there is. Instead of applying division by 10 to all calculations you make, you could modify the TG column in your data frame. So let's do that. bm enter, calculate a new column out of existing column. That would be df tg. So this is a new column, right? It has a new name. It doesn't have this name. So this will create a new column. The new column in the data frame will have this name, and it will be equal to this existing column divided by 10. Press enter, and now the data frame has been modified. As you can see, TG has been added in here. So 2.1, 4.6, 3.1, and this alt column is still having those numbers as before. If you are in the US though, you may want to add yet another column, such as df Fahrenheit. So that would be equal to df tg, tg is the new column, times 9 divided by 5 plus 32. So that's the formula to convert between Celsius and Fahrenheit. And execute and check out the data frame. So that's the new column, Fahrenheit. But we did do some sort of mistake here. Before we had done this calculation, we should have gotten rid of these minus 999 values, because what we got is that we also got these values, minus 999.9 for the new Celsius degree column, and also the Fahrenheit then was calculated out of this values. So this is messing things up, but it does have a fix. So before we do this calculation, click this cell and press A to add a new cell on top of it, above it. And then here I want to add a new column. Let's call this TG0. I'll explain you what this column will be in just a while. So TG0 will be df, the current TG with these spaces. So this TG column, which contains the -9999 values, and then you apply mask df this column again. So in square brackets, the old TG column is equal to -9999. So what I'm doing here is this. I'm creating a new column, and the values of this column will be the values of the old column without, so read this method as without. So mask without is the same thing. So without this condition, so without the values that satisfy this condition, and the condition is that the TG column is equal to -99999. And there's another argument of the mask method, and that is np.nan, and np is numpy. So import numpy as np above here, and then you do that. So numpy is another Python library. Pandas is actually based on numpy, and np.nan symbolizes non-values in numpy. So what we're doing actually here is we are replacing all those values with this special non-value. This is good because Pandas then knows that it should not do calculations on those values. So I'll print out the data frame in here just to see what we've got. And yeah, so we've got this new TG0 column with these nan values instead of -999s. And then in here, we calculate the new column on the TG0. We don't deal anymore with the TG, with the old TG column. So with that, execute df, and now the new TG has these correct values, 2.1, 4.6, and for this it does have this nan value, which is better than having -999.9. Same goes for this. Fahrenheit is equal to that. Execute df, and that's the Fahrenheit column as well, with none values for no data. And the last section is plotting. I already showed you how to do some plotting, so we used this syntax before. So we extracted out the -999 values and then we applied hist. But now that we have a clean data frame, we can simply use the TG or the Fahrenheit column, whatever you prefer, .hist. And we get the same histogram as before. So TG is the same histogram. But you might also want to view a complete plot, how the temperature has changed across days. To do that, you should use the df.plot method. And there you should specify the x. So for x, we're going to have the date column, which is this. So date column as the x in single quotes. Y will be TG, and the figure size will be something like 15:3. You can try different sizes and see what works best. So 15 stands for horizontal and 3 stands for vertical. So if you do 10, 3, it will be narrower horizontally. 15, 3 is a good size. So these are the data, the temperature values for all the years from 1870s up to 2020s, somewhere in here. The data are missing for the last years, as you can see here. So this station is probably not working anymore. But anyway, so these data, however, do not depict a very accurate picture of what's going on. So you want to plot particular data. So if you want to plot just some rows, for example, row 100 to 1000, then you'll see this. And that was the last line of code that I wanted to show you in this very long video. Thanks a lot for following, you're doing a great job. See you later. Hey, welcome back. We are back to building our REST API with Flask. So this is what we have so far, and let me give you a quick overview of what we have done and what this does, because we did some playing around with Pandas, so it's good to give you an overview. So this is a main.py file, and that's what we run to start our web app. So that's the web page of the app. And if you click that URL, it takes you to the home page. So that's the documentation. But if you visit a URL endpoint, such as this one, this is just an example, then we get that. Because in the URL we entered 10 for the station ID and the date, and so station ID and date are passed to station and date respectively, and then we return that dictionary. So that's the dictionary. For now, the temperature value is 23, so it is hard-coded in here. You see, I've just declared a variable, and then that variable is displayed next to the temperature string. So the temperature string and the value. Our purpose now is to get this temperature from the CSV data. So to be able to do that, we need to get the CSV data and place them in here. So I already gave you the data in the previous video. If you don't have them, please go to the previous video and download the data from there. So there you'll have a data.zip file and a data small.zip file. The data.zip file has 6,500 text files, and the data small.zip file has only 100 text files. So I do suggest you to get the small zip file. That would be more than enough for the purpose of this project. So this is the folder I worked on previously. Here I have the Jupyter documents and the data small folder with these 100 files, plus the metadata inside stations.txt. So I'm going to copy that entire folder and place it in my root directory here in PyCharm. So now data small is in the same directory with main.py. Do we want to add this to the Git repository? Yes, we do want to add them. So press on add, and these should be colored in green. Otherwise, you can just right click here, go to Git and go to add, if they are not colored in green in your case. Alright, so how should we get the data from these files and display them in this page? What's the logic behind that? Well, as usual, think about how do you go from the input data to the output data. So how do we get these data into Python first of all? We do get them using Pandas. So in the import statements here, import pandas as SPD, and pandas should be installed for this particular virtual environment, so make sure to install it. Now it's installing in my environment. Then once you have pandas, where do we load a data frame? Is it here, like pd read CSV, like that? Yeah, but the question is, which of the CSV files should we read here? Is it the first one, the second one, the third one? Well, we should read anything that the user wants, right? how do the users ask for a particular file? Well, they ask for a particular file through the URL they enter. So, for example, in this case here, the user entered station with ID 10, and they asked for the temperature of that particular date, year 1988, 25th of October, station 8. So that number 10 then goes in this function here. So station will be equal to 10 in this case. I can prove you that by printing out the station variable in here. Save the script and then go to the page, reload this. Oh, we got an error because Pandas is still being installed. So let's wait a few seconds. So the process was interrupted because of the error, so I'll execute this again. We get this other error here because I entered this line, so let me comment that out. So this is missing the argument, that's why we got an error. Yeah, let's run again. I want to make my point here. So for now, nothing is printed out because this function has not been yet executed. This function is only executed when the user loads a URL, an endpoint. For example, this one in here. Let's try it again. So there we get the data, but what happens in the command line is this. So station was printed out. So that means we do have the station ID in this function. Therefore, we should read the data in here. pd.read csv, and that would be data underscore small slash tg. So that path, let me copy the accurate path by going to copy path reference, and then you want to copy path from content to root. So that one in there. So I will delete that, paste this here, put it around quotes. So that's, however, for one station. So that's station 1, and it's still hard-coded. How can we inject that station into here? That's the question. Well, we should do something like, this should be a separate string, and then we should concatenate that string with the station ID. Now, to get those zeros before a number, let's say station is 10, and then you can use str station.zfill 6. That should construct a string of 6 digits. So 1, 2, 3, 4, 5, 6. So let's try again. If station is 99 this time, then this should construct that string. If station is 1001, then we should get that string. So that's the format of these file names, right? So let's apply that here, plus str station dot zfill 6 plus the .txt extension as a string. So all these are strings, right? That is a string, that is a string, and zfill is a method of strings. So it basically adds zeros to a string. The string should be representing a number, but it's not a number, so we are converting that into a string. So it's actually like the string version of number 10. So basically we're doing 10.zfill 6. That's what we're doing here, just to be clear about that. So that will give us the actual file that the user wants, and we read that file with Pandas. And so that's the first argument. I would prefer though to have this argument in a separate variable, and then I can just pass the variable here, file name. So file name represents a string, and here that's the first argument of the read CSV method. Then the second argument, remember that we had already did some exploration of the data in Jupyter, so you should open your Jupyter program and refer to the code we wrote already. So here you have also the skip rows method. So skip rows is equal to 20 because each file starts at row 21. That's the header. All these are metadata which should be ignored. So that's what the skip rows method does. And parse dates should be equal to a list of columns which should be treated as dates. We only have one column here, the date column, so copy that column name, including the spaces, which is 4 spaces, and yeah, place it inside quotes, like that. 1, 2, 3, 4 leading space and date in capital letters. Then we should extract the temperature out of that data frame for a particular date. And again, you should be referring to the Jupyter notebook. And I did teach you how to get certain cells in the get certain cells section here. So that's the code basically. So you might want to copy that cell and then paste it in here. So that should be the temperature, but of course we need to modify it slightly here. So the date in here is whatever the user enters, and that date is stored in the date variable as a string. So when the user enters the date, it's in this format: the year, the month, and the day of the month. But the dates of the date column are in this format with these dashes. So we have two options here. Either we get the user date and we add dashes between the digits to make it comply with the date column, or we force the user to enter dates with dashes in the URL. So what that means, we would need to modify the home page a little bit. So if you go to templates, home.html, you need to tell users to enter a date in this format. So give the example like that. So I would prefer to have this option, and then in here we just compare the date that the user enters, which is supposed to be with those dashes now. So we check for values of that date in the TG column, we squeeze it and divide it by 10, and that should be the temperature. So now we can delete the hard-coded temperature. And yeah, let's give this a try. So let's run main and go here. Let's try the URL now with dashes. Don't forget, you see, the date is with dashes. Paste it there. And there we go. So for station 10, the temperature was minus 0.9 for this date in October. Temperature was about minus 1 degree Celsius, which is below the water freezing point. So quite cold. And let's try another date, like 1999. So that is 9.5. 10 years later, temperature was quite higher. Let's try another station, like 19. There we get an error. So stayid 000019.txt is not in here. Is that the case? Yes. So some stations are missing. And to address that issue, we're going to improve the homepage of our API. So here next we're going to display the list of available stations with IDs along with city names so that the user knows what they can query through the URL endpoints. So if they want Rome, for example, they can see the station ID for Rome and they can query that particular city. So that's something that we will do next. For now, that was the code. So let's commit the changes and yeah, commit. That was day 30. Return temperature for any station and date. So we're committing home.html, main.py, and all the data. Unversioned files here are about.html and tutorial.html. These are files not related to our project. If you remember, I worked on those files when I was teaching you Flask. So commit the changes, and that's it for this video. Thanks a lot. Hi, in this video I'll give you the task for today's exercise, and this exercise is part 2 of yesterday's exercise. So yesterday you built this API. When the user enters, for example, sun in the URL, you return the capitalized version of sun along the definition key. So you return the definition key sun in uppercase and then the word key and sun in lowercase. So that was the code more or less of yesterday. Today you need to return the complete dictionary. So instead of returning the word in capitalized letters, sun, you return the definition of sun in this case. So that's the dictionary you should return. And of course this would work with any words like tree, for example. We have 2 definitions for tree and so on. So that's your task for today, and this completes this app as well. I'll give you the solution in the next video. See you there. Hi, in this video I'll give you the solution to the word definition API. So that's the output when the user enters, for example, tree in the URL, and the code is this. So I am importing Pandas in the import statements here above, and then I'm reading the data frame in here outside of the API function. And there is a good reason for that, I'll explain. So once I read the data, I load the data into a data frame, then I do some filtering here to extract the definition for that particular word and squeeze the data to get the actual word only. And then I construct the result dictionary where I place the definition variable I got here next to the definition string, and I return the result dictionary. Now regarding this line, should you place it here or should you place it in here? Well, for that I want to demonstrate you something. Let's print hello here, and let's print hi in here, and then run the script. Once I run the script, you'll see that hello is printed out in here, right? Now, hi was not printed out. You see there's no output for hi. If I go to the home page now, if I visit this URL, so if I load this URL now, what happens is that this API function is executed, therefore hi will be printed out. In fact, anytime you load this URL, load once, load twice, you'll see that we'll have multiple hi's printed out. However, hello is only printed out once. So hello is only printed out when the script runs. So imagine having this in a server. That means you start the server once as a programmer, and that means everything you have outside here will be executed once. but anything you have inside the functions will be executed anytime the user triggers those functions by visiting their corresponding URLs. So that's something you should keep in mind. So in this case, the question here is, should you load the data frame only once, or should you load it anytime the user visits URL? Of course, it's much more efficient to load it only once outside of these functions. If the dictionary.csv file would change for some reason, you'd get updated data from somewhere, then it would make sense to have this inside this function, because that would give the users the updated data anytime they visit this URL. However, this is not the case here. Dictionary.csv is a static file. It's not changing. These are data that are permanent here, word definitions. So it's good to have that in there. Yeah, let me remove hi and hello, and I say bye-bye. Thanks a lot. See you.